tryna tell you what to do, we're tryna play it cool. Baby, I am playing by your rules. Everything look better with a view. Why you always in a mind? Fucking around out the brain, no. I ain't tryna tell you what to do, we're tryna play it cool. Baby, I ain't playing by your rules. Everything look better with a view. I could never get attached. When I start to feel unattached, somehow I was in a feeling bad. Baby, I am not your dad. It's not all you want from me, I just want your company. Girls obvious, elephant in the room. We about to be done, I'm so confused. You're starting it, now I'm in a month. Now we arguing in my bedroom. We play games of love to avoid the depression. We've been here before and I wanna be your bed. While I was in a month, walking around acting right now. I ain't tryna tell you what to do, we're tryna play it cool. Baby, I am playing by your rules. Everything look better with a view. Why you always in a mind? Fucking around acting right now. I ain't tryna tell you what to do, we're tryna play it cool. Baby, I ain't playing by your rules. Everything look better with a view. So when you try to figure love on the regular, when you could be blowing up just like my cellular, I won't ever let a shawty got me, set me up. Only thing I need to know is you'll be wet enough. I'm talking slick back, kick back, gun sipping 40s. You can play not another day with a shawty. Mismatched fits, that was way before you know me.
So now let's move forward. So before moving, let me revise all the things that I told till now. So I have told you about Tinker CAD. That Tinker CAD is a website in which we create circuits, code blocks, and 3D designs. It is a very useful website, and we will be dealing with Ardino Uno as the topic is inventing stuff using Ardino Uno in Tinker CAD. Ardino is a device. It is a microcontroller that can control any electronical device. And we will be working with Ardino, and we will be making many projects. Now, I told you how can you log in into Tinkercad. So for doing the same, write tinkercad.com, and if you don't find this directly, then you must be coming here. You can go to the first website and you can reach it. Now, for those who does not have an account on Tinkercad, I am repeating the steps that how can you make an account. If you don't have an account, then this screen will come. Click on join now. Click on create personal account, and here you can find all the sign in options. If you already have an account, then you can just sign in. So now we will be signing in with Google. Here are all the accounts of the Google. They will appear. Now I'm choosing this account. You can choose your account. And here is our account name. Now it will load and it will take us to the dashboard. Here is the dashboard of Tinkercad. So this is the 3D designing part, but we will be dealing with circuits. So here you can see the circuits. Click on this and now click on this button, create new circuit. Now it will load and a blank workspace will appear. So here is our blank workspace. So for starting, first you have to rename your circuit. Although it's not necessary, but you can always rename your circuit so that it would be easy to identify when you enter next time. So here I am writing day 1. Now I will be taking this LED out here. So here is our LED. So first you need to know that what is electricity. So electricity, when we talk about electricity, a term comes in our mind that is electric current. So electric current is basically the flow of electrons. The flow of electrons is known as electric current. So I think this you all must be knowing. Now we will take a coin battery of 3 volts. Now I will tell you that what is the recommendations, what is the things that you need to provide to this LED for glowing the circuit. So it needs 3.3 volts. So now if I just connect this like this is anode and this is cathode. So I will tell you in just a minute that what is anode and what is cathode. Now if I click on start simulation, so here it needs, you can see it recommends maximum of 20.0 milliampere. So it is getting more current, but it's fine because it's glowing. But here is a danger. So this LED must, so this LED will burst or it will not glow for very long time. So for doing the same, there is one more device. So I will tell about it in just a minute. But first let's understand that what is cathode and what is anode. So now I'm stopping the simulation and I will delete these wires. So two this LED has two parts, that is anode and cathode. Anode is the positive. So positive we always connect with positive. This is the positive, anode is the positive, so we connect it. And we always represent positive with red color. So if you click on this wire, a small menu appears. Click on the color and make it red. Now is a cathode. Cathode is the negative, so we will connect it with the negative terminal of the battery. Negative is represented by black, so we will make the color black. So here is our circuit ready. See, it's glowing, but still a danger mark is there. To prevent this danger mark, to remove this danger mark, we need to do one thing. We need to take out this resistor. So this is a new component, and today we are going to learn about this component only. After that, we will learn about the next components tomorrow. So it is having terminal 1 and terminal 2. It is not having any positive or negative. So now here a question must be coming in our mind that why some components have positive and negative terminals and why some component doesn't have. So the components that have positive and negative terminals are known as polar components. They are polar, and this resistor, it has terminal 1 and terminal 2. So the components that have terminal 1 and 2 and they does not have positive or negative, so these components are known as non-polar components. So you can connect resistor as it is a non-polar, so you can connect it anywhere. So if I delete the positive wire, okay, so I will delete the negative, not the positive. You can also delete the positive, it doesn't matter. And you can move it from here, rotate it, or you can press Shift plus R by selecting it. Now I will connect it here, and in the below terminal I will take a wire and I will connect it to the negative, and here it turns black. Now when I start the simulation, see, it is not showing any danger mark now. Now a important thing about resistor, that is, this resistor you must be seeing it has some colored bands. These colored bands are very important. This does not affect the resistor or does any work for the resistor, but these are for calculating the resistance value. So the resistance value of the resistor is in ohms. This resistor basically resists the currents and it prevents the overflow of current. Like when I started the simulation, so the extra current that LED doesn't need, resistor is resisting that, and the required current is only passing. This is the work of resistor. Resistor is also used in heating effect of electric current. When the electrons they pass and the extra electricity that is passing when the resistor erases that, then the resist then the current that is resisted by the resistor, that current, the electrons try to go out of the wire, and in that case it forms heat, and it is this resistor is used in press and in many electrical components. So these so the value of resistance is in ohms. See, it is here in kilo ohms. So 100 ohms is equal to 1 kilo ohm. See, it's the same. Earlier also, if I do this 1 and then kilo ohm, see, it is glowing. If I do it 100 and then ohm, then it's also glowing. Now you must have noticed a change that whenever I change the value and the unit of measurement, then these color bands are also changing. So this is known as color coding. So color coding, I have prepared a chart of color coding, but that we will not study today as it will be messed up if I will tell you everything today. So now let's study about this. This is also a battery, but you may see some changes that this battery, coin battery, was of 3 volts, but this battery is of 1.5 volts. Now, what is volt and what is current? So, current is the flow of electrons, and voltage is the term that makes current flow. So though many people get confused in between this, but it's very easy and it is easy to understand also. And there is one more advantage in this battery that you can make batteries with this. So a cell, it is a single piece of cell that is this I have taken, but a battery is a combination of two or more cells. So if I make it 2, then C. If I make it 4, so 4 cells. So this is how it works. So this needs only 3 volts maximum, otherwise it get burst. So 1.5 plus 1.5 is 3, and now we will just delete this. For deleting, you can select the component and go here or click the delete key. Now, like this, I have connected C, negative and positive. Okay, it's bursting, means it getting extra current. So now in this case, again, we'll connect a resistor. So now it works perfectly fine. There are more units also. See, if you change the unit, then the color also changes and the value of resistance also changes. Okay, so this is how a resistor works. So I hope you have understood this. Today we learnt about 3 components. First was a LED, second was a resistor, third was battery, and we learnt about 2 batteries. First was 3.4 3-volt coin battery and 1.5-volt battery. Now this component is a LED. So this LED means light emitting diodes. Like this LED, a more component is there. You can type here light bulb in the search panel. Take this light bulb and see. This light bulb is also a non-polar component. Now if we just put this here and this resistor here, and now I will delete the LED. Now I will place the negative here. Now see. So this bulb needs even less electricity than the LEDs. See, if you connect this directly with here, then let's see what happens. Okay, so it's glowing, but it's glowing a little bit more darker. So now let's make it 3 batteries. Now let's make it 4 batteries. And now let's try with the new battery, that is 9-volt battery. So these bulbs are more used than LEDs, but LEDs are also very good for usage. So this our tomorrow's topic is LED RGB and this diode. So we will learn about two more components tomorrow. And yes, we will also learn about polarized capacitor. So these three are also very useful components. We will make the circuits of these three and we will enjoy with the session. And by the time we still have 15 we have still 5-10 minutes left, so I will tell you about a component. In your search bar you can type multimeter and take this out. This multimeter is also a very useful component that is used for calculating, means that is used for checking the amount of electricity flowing. See, if I just connect it like this, okay, sorry, not like this. If I take this coin battery and connect it and start the simulation. So it's 3-volt coin battery and this multimeter is showing that 3 volt is passing. Here you must be seeing 3 small buttons. If you go to A, this is the current. So the unit of current is ampere. Now R, there is a error because R is for resistance and we have not used any resistor here, so it can't tell us the resistance value. Tomorrow I will also tell you formula for calculating resistance, ampere, that is amount of current passing, and amount of voltage. That will be very useful for you. So till then, bye bye. I am ending the stream. I hope you enjoyed the session very much. Please join the further sessions. Bye.